Nintendo Switch, let me show you what's going on. Rule number one, we always want to check the port before we test anything else. It's solid. I don't see any pins sticking out or bent, so it is safe to do power test. The first test we'll perform is with our benchtop PSU. Let's see what it's doing. We're looking at PSU channel 1. And we have a 0.06 draw, which is basically nothing. Both sides of the charger. Let's see if we can activate the OEM charger. No on that side, but this meter typically only works on one side. Okay, we're not activating the OEM charger at all, so there's definitely a problem somewhere between the port and I would say the M92T36, but the only way to know is to crack it open and find out. This video is brought to you by PCB. They're running some huge specials. We'll talk more about them in a little bit. We have it disassembled enough to do some testing. When you crack it open, this is the orientation of the board, and these are the common fault testing zones we'll be testing. We're going to start with the M92T36 as we know the switch is not communicating with the charger. If we don't find anything there, we'll work our way up the board to the MOSFETs and test pads and test around the BQ24193. Let's begin our testing. We're going to be testing the capacitors around the chip, and the lines we're most concerned about are the ones going directly to the chips. That's what we're going to be measuring. But actually the first capacitor we're going to be testing is connected to the Pi 3 USB on the back of the board, and the line we're worried about is the one going to the chip, and it appears to be fine. So we'll continue our testing. Now this capacitor has two lines going to the chip. In that case, only one side should be ground, and it is. Okay, so far everything is checking out. Let's move up the board. We'll check around our MOSFET area. Everything looks good there. Gonna check our invincible fuse. See if it's still being invincible. And it is. Alright, the next area we're going to test is these test pads. None of these test pads in this area should have a pathway to ground. Oh, and we have a short right here. Now I'm pretty sure what this short could be. However, I do have a thermal camera and I can show you what it is. Let's go ahead and continue our tests. Make sure we don't have anything else shorted. Neither of these test pads should have a pathway to ground. This coil should not have a pathway to ground, but it should have continuity going through it. Same rules apply to the BQ24193 as the M92T36. Has multiple capacitors with multiple lines going to the chip, so in that case only one side should be ground. So we know this test pad is shorted to ground. It should not be. So our next step is going to be to inject voltage and see where that short is coming from. On PSU channel 2, we're going to inject voltage. We're going to put our negative probe on the port, and then we're going to put our positive probe on our shorted test pad. And that is not enough to warm anything up, so we're going to have to increment up. We'll bring it up by 1 volt. Test again. 116 is not enough. Let's increment it up again. And there we go. So at 3 volts, 0.26 amps, our M92T36 is lighting up like a Christmas tree. So now we know this test pad is definitively connected to the M92T36, and this is why we check our test pads. We're going to need to disassemble entirely so that we can change out that chip. Go from there. So 130 degrees will usually be enough to release the adhesive on these pads. Sometimes if it's really old, it just will not release. Like so. For your orientation purposes, we'll be working on side B, and we have zeroed in on the M92T36 as our problem. So we'll remove the chip, put a new one on, and test again. Let's add some flux. Approach-wise, I have the new chip staged off to the side in the proper orientation, so hopefully I can just pick it up and put it back on as soon as I get the other one off. In order to remove this chip, I must turn on my equipment, and while I turn on my equipment, let me throw up my expected temperatures for this job. These temperatures are brought to you by the associate links in the description. If you go to my video description and click on one of these links and buy any of this equipment, a small portion of that purchase will go to supporting the channel. And I greatly appreciate you. It won't cost you an extra dime. In an ideal world, I will not need the irons for this job. Something can always go awry though. What we're looking for is all these little pads to wet. We don't even want to touch the chip until all those pads have wetted. Clean pull. Let's grab our new chip. Re-wet the solder. We're looking for that center pad to wet. Okay. When we place it, we want to make sure that center pad makes contact before we let go. Center it up. Remove your heat. Let it tack down. Put a little downward pressure, not too much. re-wet, and push it flat to the board. Everything looks aligned. Everything looks aligned. We need to clean up that little blob. Looks good. Looks good. Let's clean up our little blob. Before we apply power, let's make sure our short has been relieved. And it has. It is gone. Next step is to clean off, and then we'll do our power test. PCB Way is offering up to 60% off flexible PCB, and that's just one of their services. Also check out standard PCB, advanced PCB, assembly, SMD stencil, CNC, and 3D printing. Click on my link in the description and start your project today. We're ready to conduct some power testing. This is not always the most reliable test, so don't draw any major conclusions from it. But what I basically want to see here is the switch react to a charger being plugged into it on both sides of the port. It's not always an ideal world, but that looks pretty normal, as does that. Though I'd like it to not be just sticking there. That could or could not be a problem. We have grabbed our modified iPhone power squid and our OEM charger. We have modified it with nintendoswitch and nintendoswitch Lite battery connectors. And what we're going to do is try to activate it using our OEM charger. And all that's required is a quick plug in and unplug. And what we wanted to see here was it actually boot. That would have been nice. Not really certain as to why we're not seeing it boot. We may have another problem. Let's see if we're drawing 15 volts. Oh, we're bouncing all over the place. That is absolutely not normal. But now we're 15 volts. It's very strange. Try that again. Okay, 15 volts. Let's try the battery squid one more time. Still literally nothing. Oh wait, okay. Now it's acting like it's booting. Check and see if it's docking. Not on that side. Not on either side. Okay, we're for sure not docking, so we definitely have another problem. Let's take a look at side A and test around our Pi 3 USB and the filters, just to see if we have a problem there. Let's check the Pi 3 USB, and just like the other chips, the line we're concerned about on this capacitor is the one going to the chip, and it appears to be fine. Let's check our filters. We don't want any shorts on these filters. None of them should have a pathway to the ground. None do, but we should have continuity going through them. And we do. None of them should have continuity going side to side. And they don't. Okay, interesting. Question then becomes, do we have a problem with our chip? Let's try again with our squid. Maybe it's just being glitchy. But so far that is not what I'm seeing here. It's not just being glitchy. We're going to try another chip. Say this one's a strange one because we're not really getting a definitive indication of what is causing the problem. Again, wait for every pad to wet before you even touch it. Grab the other one, which we had staged just like the first one. Re-wet every pad, make sure that center pad is wet too. Place it carefully. Center it up. Remove your heat. Press down gently. Re-wet. And press flat. Okay, that side looks good. That side looks good. That side isn't perfect, but it's all connected. And that side looks good. I'm not going to worry about the cleanup just yet. I just want to see if we have changed our behavior any. So PSU channel 2. Whoa, that jumped up in amperage very quickly. It was strange. Try that again. Yeah, it shouldn't jump up right to that amperage right away. That's very weird. I plugged my housing battery to it. Okay, it looks like it's stuck at 0.47. That is not necessarily a good sign. Oh wait, well there we go, we're fast charging. Strange. And now we're docking. Okay, so it appears to have been the chip. I don't know why it was acting so weird with my dongle though. I'm going to power this off and put the dongle back on and see if we can reproduce. I am not used to it jumping up in that amperage range so quickly, but it may just be how this one's behaving. Let's give it a second. It's just really high amperage. Stick the dock to it again, and there we go. We're docking. Okay. It's throwing me a little bit off because that seems like unusually high current. It usually will start off low and then climb up, but for some reason it just started out at 0.35. It's a little bit different. I think the new chip is solving the problem, but we'll put it back together and run it through a battery test and find out for sure. We're back up and running on its battery. It took a while for it to charge. It was a little bit dead. Its Joy-Cons are quite dead, but charging. Make sure we're picking up our networks, and we are. And we have Bluetooth. Make sure it's picking up our game. Street Fighter! As you can see on the USB meter, we are charging at 15 volts, 1 amp. So fast charging. Excellent. If you got value out of this video, I think you'll get value out of this one, and I'll see you there.